welcome back. Moving to the next, that is number 28. 28. It says compare the following numbers. The following number pairs. Basically, the numbers are given in pairs. You have to compare the number pairs. The number pairs are given as 0 and minus 9 by 5, minus 17 by 20, minus 13 by 20, 40 by 29, and 141 upon 29. These are the three numbers. So starting with the first one, this one is 0. In number line, if I take 0, any number on the left hand side will be signed with a negative sign. So any number on the left hand side will be less than 0. So here 0 is greater than minus 9 by 5. So it can be compared easily. And if I see this number, both are negative in nature, but on negative side the tendency of growing lesser when the numerator increases. That means more value on negative side will be a smaller number. So that means minus 17 by 20, as because here denominator is same, so it would not be a disturbance for the comparison. So minus 7 by is lesser than minus 13 by 20, because minus 17 is coming further left to the minus 13. And last one, it is on the positive side. In positive it is very easy to compare, because smaller the number it will be smaller, bigger the number it will be furthest on the right hand side it will be bigger. So 40 by 29, as because here also the denominators are same, so you can straightaway say this is. So this is very easy, but sometimes this may be confusion when you are comparing some number this side or some number that side, or be more confusing when you are comparing any two negative numbers. Okay, so next come 29. So 29 says that write the following decimal number. Write the following decimal number and state what expansion it is. What expansion it is. Okay, the numbers are given as 40 upon 100, 9 upon 10, 9 upon 37, 103 upon 5. So that means one thing you have to do, you have to convert it in decimal, and then you have to say whether it is terminating or non-terminating. So here I can say this number, if I reduce the decimal, I reduce the fraction, it will be 2 by 5, and it is nothing but 0.4. So it is a terminating, and this is a conversion into decimal. The next is very easy, it will be 0.9, so it is also terminating. But 1 upon 37, if I take, it is not a perfectly divisible. 1 is perfectly divisible by 37. If I go on doing your means if I try to divide it with this divisor 37, I will not get any perfect terminating number after the decimal. So if I take 0, then 0, 37 into 2 times 74, it will give you 626. 0 already there, 37 means how many times? 7 times, let's say 49, 4, 25. So it will give you 260 by 7 to 5. 7 7 49, 4, this. So this is again 1 is coming. No, it is again repeating. Okay, yes. So that means 1 is coming. So we are here on the same phase. So this I can say this is under bar. So my assumption is wrong. So this also a terminating, because this 3 numbers are repeating. So I can put it like that. It will be nothing but, if I take 9 here, so 9 will repeat every time. So if I multiply it with 9 into 0.027 bar, so it is a terminating one. Any number which is terminating multiplied with any number will remain terminating. So, and the last one is 220.6. So this is also terminating. So all 4 numbers are terminating, and this is the representation in decimal. Okay. So next comes 30. Insert one rational number between 3/5 and 7/9. So this is again both the numerator and denominator are changing. It is not that every time I am getting the same denominator. So how will you decide that? So you know that if 2 rational numbers are there, a and b, so in between, if only one rational number has to be available, this is definitely be this one. This will be definitely one of the rational number that I will find between this. So from this theorem, if I say 7/9, if I divide it by 2, I will definitely get the rational number intended. So that will be 27 plus 35 here, 49, 90 will be there. So if I add it, it will be 262 by 90. If I reduce it, I will get 39 by 45. So this will be answer. So this is the theorem. If any two rational numbers there in between, this will definitely be one of the rational number. Okay. So next come 31. Says the product of 40 odd numbers is the product of 40 odd numbers is. So there is no much thought of that, as I already have said in earlier episodes, that multiplications of odd is always a odd number. Whatever be the series of number you are multiplying, if all numbers are odd, then definitely you will get odd. But in between any even number inserted, that result will change into even. In that case, and the other cases where all even numbers are multiplied, any number of even number being multiplied, then the result will definitely be an even. So there is no ambiguity. Even if it is 40 or 400 or 4000, the result will be odd only. Okay. Next comes 32. The 6 digits number which is given by 54, 32, 1a is divisible by 9, where a is a single digit whole number. Then you have to find a. What is a? Now, as the number is divisible by 9, so the rule for 9 is you have to sum of all the numbers, and if it is divisible by 9, then the number itself is divisible by 9. Now, if I add the numbers, it is 5 plus 4 plus 3 plus 2 plus 1 plus a. It has to be divisible by 9. Now let's see on the numerator what I get. It is 9 plus 15 plus 1, 16 plus a by 9. Now at least if the number has to be divisible by 9, the result must be, it cannot be 1 because it is crossing 16. So the next decimal, next integer after the division, I would get 2 definitely. So in that case, if I equalize with the 2, it will give you 18 minus 16. That means equal to 2. The least possible number that will satisfy the number to be divisible by 9 has to be, a should be of 2. So if I take the number as 5, 4, 3, 2, 1 and 2, let's see if it is divisible by 9 or not. Any other number can be possible, but the least one that is following that number is taking a is equal to 2, 9, 54, then 32, then it will be 0 here, 5, 1, 45, then here 11, 6, the sum of the numbers 9, oh sorry, I have mistaken the number, sorry, the summation I have done wrong, because 5 plus 4 plus 3 plus 2 plus 1 plus a, so here summation is 5 plus 4, 9 plus 3, 9 plus 3, 12, 12 plus 2, 12 plus 2, 14 plus 1, 15, sorry, 15 plus a by 9. So if it is equal to 2, then a becomes 18 minus 15, that is equal to 3, sorry. So if I take the 3 in last position, that the value would be 5, 4, 3, 2, 1 and 3. Now let's see, 9, 6, 54, then 3, 2, taking 0 here, 3, 27, 5, 1, 5, 9, 45, then it is 6, 3, it is divisible. So I can get a definite integer after division. There is no remainder. So that means this number. So your a value is 3. Okay. So this is for today. In the next class I will continue from number 33. Thank you.